So the available filters are self-explanatory and can be used in any combination. For example, you can look at this in analyzing the attack surface. So remember, the topic of this lesson is reducing the attack surface. The same list of heat map filter options are also available on the associate policy, so you can look at your application policy. Okay, so now we more or less caught up to where we were. We were about to start with this. So behavioral tuning. So how do we tune the behavior? You use the discovered heat map information to secure application behavior in the environment. You can also use this information to research specific application behavior. You determine whether behaviors are required for normal operations and need to be allowed, or you determine if applications are exhibiting unexpected behaviors that are determined to be malicious or need to be denied. The heat map includes a variety of tools that you can use to help you secure your application environment. And one of them is the quick tune feature. So the heat map includes a variety of tools that you can use to help you secure your application. It's almost like the workflow or the quick tune feature. So heat map includes a variety of tools that you can use to help you did in the lab yesterday to basically fix your security. The heat map includes a variety of tools that you can use to help you then did in the lab yesterday to basically in most situations a large number of application pairs will not detected in an environment are displayed as zero behavior or zero activity. Because these pairs are not used, it makes no sense to block these from potential applications. You can block each application pair individually, or to save time, you can use quick tune. Quick tune basically recognize all the zero prevalence pairs and in one step set the policy action to deny it. The bulk changes are added to the review changes, zero prevalence pairs, click on the review changes. Be sure to save the changes and the review changes saves the policy. In addition to the quick tune, the heat map also includes a tool that allows you to make bulk action updates to application based on displayed filter. For example, you filter all applications that are displayed in heat map as 9, and in one step you can change them to monitor, so you can then immediately make. So bulk changes, as the word is implying, is changing or adding changes to many method. So bulk changes, as the word is implying, is changing or adding changes to many method. So bulk changes, as the word is implying, is changing or adding changes. So individual from pair tune. So you can also select an application to see information about this behavior. So go to the job for Excel and see the Excel on job, what happens to see information about policy behavior installation. So what happens, you can again directly update this by clicking the allow, monitor, or deny. So see here, Symantec tells you we recommend that you block this by clicking the allow, monitor, or deny. So see here, Symantec tells you we recommend that you block this application or block this behavior. So Symantec tells you we recommend that you block this application. We also have what we call the adaptive protection or behavior adaptation, and this basically is specific adaptations for behavior will be implemented. So it will change over time potentially. So what happens is, for example, adaptations allow individual granularity in controlling applications. So what happens is, for example, in controlling application behavior in granularity in controlling application. For example, app control. So app control trust Excel too long. So we know Excel is safe, right? Adaptive protection may restrict some behaviors like macros, channel settings, and allow others, like maybe pull sales numbers from a CRM service, so go to another server, that's allowed. But then look at another client, a CLC, or pull sales numbers from a CRM command and control client, monitor this. We don't know the slide, but we monitor the behavior. So it keeps an eye on the applications, and this is what the system does continuously. This is why the adaptive protection. So again, if you look at this, as I mentioned yesterday and earlier this week, it looks and it adapts to what you're doing. No system is exactly the same. We know what's safe, we know what's not allowed, but it keeps on adapting and it keeps on checking what people are doing. We know what's safe, we know what's not. So look at your behavior, observe behavior and command, to see this. And every time you open, it gathers that telemetry from your device. So the adaptation, once adaptive policy is in place, you can do your own customization, of course. But let's say a behavior is set to blocking mode in the adaptive protection policy. The telemetry data indicates that the minority of agents need exceptions to the blocking rule on a granular basis. And then adaptive policy or protection policy provides the granular behavior needed to the general blocking rule. And this is generated from the telemetry gathered from your organization and compared to malicious lay of the land command. So it defines which behaviors are allowed, and it automatically adapts based on the ICDM. So this is a nice thing that Symantec will globally, let's say there's a new virus or a new way of attacking or making Excel vulnerable. Symantec will know that because of all the users in the world that's using this, and then essentially pick up that people are using this and this device or application is now vulnerable or it's doing certain things that we should not do. And that is basically what the adaptive policy will be doing all the time. You can see the adaptions, and adaptions are automatically pushed from the ICDM to the endpoint, as I just mentioned. And a list can be found on the heat map when you hover over the specific application and the application pair. So as you hover over the system, you can see then what was adapted or what has not been adapted. Some recommendations: use a sample group with genuine applications and processes running to gather this information or gather this telemetry. Leave the behaviors in monitoring mode for up to a week to learn what's happening. Deny zero prevalence behaviors. Gradually introduce blocking or the medium prevalence. Roll out in production. So monitor this, manage this intensively before you actually implement this. It's quite cool. It's an amazing feature. It really makes your life a lot easier. But if you're not used to this, or if this is new to you, do this gradually. There's no rush. Well, there is a rush for security, but you can do this, do it as a good project. Heat map application behavior pairs that indicate behavior are displayed in the heat map based on events. In some cases, when you select an application pair, you will also see view events on the display. If you can view the event, you can see more information. When you click, you're directed to the ICDM investigate page. And from this, you'll see a filtered list that includes only events associated with the detected behavior. And the lab will actually really explain this in much more details. So the ICDM also creates a task list. So you'll do this in the lab. You've also looked at this yesterday in a bit. So the task list to help admins concentrate on issues and concerns that may need immediate attention. The My task page list includes adaptive protection tasks that are associated with adaptive data, and the data is also shown in the heat map. And many heat map application behavior pairs include a Symantec recommended course of action. You can also use adaptive protection task in the My Task list to see additional information about the Symantec recommendations. All right, let's look at the device group assignment and analysis. So we talked about this. We can assign this to different groups. So we see an organization that has two adaptive protection policies that is representing or attached to two different sets of application requirements. And that's pretty straightforward. Really, we know different groups. So look, the first policy, we can see then, go to that policy is your adaptive protection for, which one was that? Default, adaptive for behavior insight. So as you expect, you can see that the policy is assigned to three devices in one group. So three devices via one group. And you see that this map is relevant for endpoints assigned to the adaptive policy. For this heat map, you have the ability to research applications and adjust the behavior. So we can fine tune that for that specific policy as well. On the second policy, you'll see that basically this heat map is relevant for endpoints assigned to the R&D group, but at this moment there's 0 devices attached to this. You can also research application behavior. See, there's the last updated date. You can check against and adjust the application behavior. It is, by the way, both of these and all of these heat maps, by the way, are not in 100% real time. It will probably take a little bit of time to actually go and be pulled through. So be aware, it's not 100% accurate. Well, it's accurate, but it's not in real time. So it normally lags a little bit. So just like you see, I mean, it's everything you need to make sure that the clients are checked in and so on. Okay. So basically, what the heat map benefits, the ability to exactly fine tune the application behavior according to your organization's needs and individual device group requirements. So we looked at adaptive protection, the behavioral insight and policy tuning, how to interpret and how to use the heat map, how to use the heat map to tune the adaptive policy, and also how to customize this. So to just summarize, use this, take your time to get this implemented. Don't rush this. Application control is much less complex in a way, but it also uses the heat map and it also uses that intelligence and information gathered through there. Um, so monitor what you're doing, what's happening in the environment all the time. So again, and think about this and implement this carefully as you need the stuff. So don't rush, don't be silly, don't push things out just because you have to or you want to. Take care, plan this properly, and make sure that you're doing the right thing. Because again, it will have an impact on people's experience of the applications and the systems and so on. Okay, let's look at applications. How does application control work? So application and application control. It used to be called it's still called in SEP. It's still called application and device control. But we use a similar kind of features. Yeah. So first of all, application. So we talked about devices stuff yesterday. But a typical organization will run a wide range of devices from fixed function devices to high change or endpoints. Each endpoint need to be appropriately protected. Endpoint application control can protect them all. Stuff like fixed function devices like ATMs. Okay, let me just see. Do we have any feature in DLP which returns logs? Yeah. I mean, DLP also create logs and stuff, so you can publish it to a syslog monitor, any SIM application. So there's also the IT analytics that it integrates with that gathers the data. So you can get all of that information absolutely in DLP, Anaga. So DLP will do that for you, yes. You just tell DLP you create a flex response rule And basically, not really flex response. Flex response for third party, but you can do a normal rule that will basically any additions or any changes or any logs that it publishes it in your syslog server or integrate this into your SIM environment. So obviously, so look at cash machines, POS, like point of sales or at supermarkets and stuff. We also have intermittently connected endpoints like laptops that will have a hardened build. Legacy systems, old machines could be variable, end of life. So you see here, I'm not highlighting every single thing here, but that's basically, you can see this stuff here, the potential information. And then high change endpoints like enterprise and so on. So we have different applications, and each of these will have a different application control requirement. So applications will make their way in a variety of will make their way onto systems in a variety of manners via emails, USB, downloads, and so on. Applications could be installed, and now you can deny the launch of any applications that's not explicitly trusted. So you can have a deny list or an allow list as you like. Right. And I think in the lab, if I recall correctly, you will work with blocking Pinterest as an application. Oh, also website. That's a website, yes. Okay. So you can have an allow list or a deny list. It used to be called a blacklist and a whitelist, so it's just being gradually changed to an allow list and a block list. So how does it work? I mean, and pretty much we have something called file discovery. Applications will make their way into the environment, and then SES complete will create a catalog of these files. Okay, so first of all, I'm going to go to this enable full disk discovery scan. This basically are systems and files that run through the environment. You can, as you develop your application policy, you can use this list to sort, filter, and analyze files based on several characteristics. Having a good understanding of the files will also help you as you develop your application control strategy. You can also use this list to add files directly to an application control. The process that's used to build this inventory is managed from the system policy. When the scan option is enabled, the initial inventory scan takes place and then every 24 hours. So it will run every 24 hours, basically. It gathers information like EXEs, bin, there's no reason to go to WAV and MP3s and those kind of things. It doesn't really, the purpose of this option is not to see for viruses or stuff. It's really to check if anything is just what applications are running. Only thing you can do is switch it on and off. You can't change the schedule. It runs every 24 hours. You can't change anything. To implement this, you can configure an app control policy. There's default app control policies, of course. You can edit this or you can create a new app control policy. So just be in mind, like many things, if you create your own policy, use the template as well. Okay. Select the policy template, like anything. You then be aware that out of the box, app control policies are not assigned to any groups. You need to assign it to a specific group. Right. You will have to check. The system doesn't know what's a false positive or a false negative. You will have to go through and figure out what are false positives or false negatives. This depending on your reports and your report requirements. So you'll have to filter this. There's no filter for false positive. You will need to, and this is even in DLP, that you need to go through all of these one by one to figure out which is false positive or not. You don't know. I mean, if there's a list of false positives wouldn't happen. So there's no false positives. Really, it depends on your settings. So you're going to have to look at your incidents and your stuff one by one. And then you assign your policy. How do we use this app control then? First of all, the associated settings. You see that you can configure several policy setting combinations, and the sections are general settings, which is a default deny, or allow semantic trusted. So this will help you. So Symantec has a bunch of has a list of files and applications that's safe, like Word, well, the Office suite, Teams, Zoom, WebEx, um, Chrome, Firefox, Microsoft Edge. Um, Let me look at stuff. If I look at my thing, so stuff like if I'm trying to look at my menu here, my application. So my 3D viewer, Adobe, calendar, calculator, camera, clock, Cortana. Why do I still have Cortana? Um, Firefox, private browsing, free trials, Chrome, Google Drive, HP. I have an HP laptop, so there's a whole bunch of HP stuff here. Intel graphics, Mail, Maps, Office 365, which again is, I shouldn't have that. Clipchamp, Whiteboard, Netflix. I have Netflix on my laptop. Norton 360. I have Norton. OneDrive, OneNote for Windows, Outlook, Paint, all the different paints and photo apps. Skype. Sheesh, I still have Skype. Solitaire, Sound Recorder. Maybe I should run on my laptop. VMware. I've got a VDI with Veritas that I use occasionally. Web, WhatsApp, Windows Backup, Xbox, Game Center, and Zoom, and all of that. So those are just a list of some of the stuff that's on my laptop, and most of them are semantic trusted. They're used all over the world. We can also add a default denial, which is basically deny the launch of applications that do not match any rule. This is very complex. This is going to be, you need a lot of files and a lot of hard work to do that. Do we want to monitor strict enforcement or enforce with overrides? So enforce the policy, but let users override deny actions. And this will gather intelligence and information that you can now change and edit certain things. And then custom rules, which is allow or deny, which you can change. So the default deny, I just pretty much mentioned this already. Now there's a semantic trusted, and do you want to allow semantic trusted? This is based on the reputation, the signature, and source of the file, and basically um, all files that meet the allow semantic trusted are by definition added to the custom list. So be careful that sometimes this may allow stuff that you do not want. Let's say, for example, one of my customers, so I do training for a variety of companies, Symantec or Broadcom is one of them. We use WebEx. But for some other applications, I use Zoom. Now, I did a training for a bank in South Africa, which Zoom is blocked. So they don't want Zoom to work. So imagine if they had this allow semantic trusted, Zoom would be allowed because Zoom is allowed for semantic. So this is where custom rules will come in, where you need to change or add your own policies and own applications here. Monitoring your settings. So a monitor only will generate events but will not enforce rules. You're going to have strict enforcement where enforce the policy rules, unenforced with overrides, as I mentioned this already. So here is monitor only, but we can also add certain things. So it's used to test the impact of any configuration. You can also filter for detected apps to see what's happening. Strict enforcement enables application. This basically is very strict. It's blocked. Blocked by your environment to protect your device. Okay. We can also do strict enforcement with overrides. This provides some flexibility of some apps that are blocked by app control policy. Enforce with overrides give an endpoint user the opportunity to request an override of some denied apps. And it's also important to note that apps are assigned to a custom rule deny list, and this cannot be overridden. The list of apps for which an override can be requested depends on several app control settings. Okay. And you can let the users then override. That's then now added to a list. Okay, your security block. You can choose to override this, but we recommend that you choose with proceed with caution. It's pretty straightforward. You can confirm yes. If you cancel, it will now be blocked. If you confirm, it will be allowed to run. When an override is requested, several things take place. So this is now go back, override, and confirm. The override is added to the client's or the agent's setting or the agent's on the app list. This list cannot be viewed or edited, so you can't see this. But you can clear the list by uninstalling and reinstall the agent. So in other words, it sits on the laptop and is then allowed. Yeah, it's not going to be a global allow, but basically is going to be for that specific user. But then detected user override requests are added to the event list in the investigate view. So you can see that Peter has allow out FileZilla or Notepad or whatever. So you can see here, there's a investigate and click under user overrides. The user override can be used to see the number of events, and you can go. You can also, it's very important or recommended the file name. So remember that columns. So add that to the column list, the file name, so it's easy to see which file was added. You can now gather more information. See there and there. There's also guys and ladies and gents. There's the hash. So you can also use that hash to maybe add it to a deny list later on or to add it to an allow list. You can select a file to see the details. The third thing that happens after the override is added to the override app list on the laptop as well as on the investigate view. The third thing that happens is analyze drift. As more and more application overrides are requested, you can learn more about denied files that your users need to accomplish. And this is called application drift. As an administrator, you can monitor this drift and then decide if you want to add these drifted applications to an app control rule, either to the allow list or to the deny list. To manage this application drift, you can use the drift option to basically from the bar associated. From the analyze user overrides, you can choose which apps you want to manage with app control policy. You select the apps from the analyze user. Even though it seems a bit redundant, you can also have an option to choose allow or deny the drifted rules. All right. So other settings then, if the trusted, the allow semantic trusted setting and general settings meet the need of your organization, you can also simply leave this option enabled and then monitor your application activity. If you desire to have more precise managed applications, you can also use custom rules. Custom rules will take precedence over the general rules. You cannot override custom deny rules. So custom deny rules are from the admin point of view, not from the user. Each rule must be a part of a rule set. And then rule sets contain either all deny rules or all allow rules. A rule cannot include both allow and deny rules. To create an add or a deny rule, you select the allow or deny button and then select add rule. And the interface for this rule is the same. You see that the rule name and rule set name are required fields and they can be select a rule, create a new rule. You'll do this in lab exactly for Chrome. What else do you do it for? I can't remember. I did it yesterday. Geez, man, short-term memory. And for Microsoft applications, so you add a rule. So after you provide a custom rule, you can give information. So this way we look at the signer, there's the hashes and so on. There's the select the file hash. The file hash, then you select whatever we need. So select the file hash. So we have the name, add, and then select the file hash. And sorry, it's a stupid screenshot. So it will show you this screen, or similar to this screen. We now tick a box, and that is in the back. So it shows you here, which is stupid. Really crappy screenshot. I don't know why the screenshot is doing that, but then you then select the file hash of that app, and it's then added. You can also do it a different way. You can use the discovered items list as a starting point. So you can then see what was discovered. So go click on the endpoint files and see what's happened. And then add a rule to allow Chrome, for example. You can use the discovered items view capability to find any file for which you want to create a rule. After you found the file from discovered, you can also click on more actions, add to app control policy, and select the policy and then allow or block. So this, you don't have to copy and paste the hash value. You just look at the discovered file items and say discovered items and say yes, add this to be allowed. All right, and managing your customer rules, manage your rules, all of that. Okay, so let's look at an example. App control profile. So remember, just revisit or rehash. You can have allow semantic trusted, monitor only mode. You could have a precise allow deny list, and then also do active drift analysis. So this is something for fixed function devices like an ATM or maybe if you fly the check-in machines and those kind of things. Anything that you can't do it from, or the cashier's machines, or when you go to the supermarket kiosks. Again, they will have allow semantic trusted, strict enforcement, and limited allow list. So for similar to enterprise, but more strict. Then legacy machines allow semantic trusted, enforce with overrides, will have a comprehensive allow and deny list. And then sensitive environments. So if the environment is sensitive, so maybe R&D, allow semantic trusted, strict enforcement, and will have a comprehensive allow and deny list. Lastly, for this application control, we can run reports, and obviously report template types, there's a whole bunch. You can create one. You select create report template. For app control, you have denied files report. You can also override analysis, intrusion prevention, or whatever. So denied files, run the report, and there's a nice report. Right. So we looked at application control, we looked at policy implementation, configuring and using app control, and then look at a bunch of reports. Okay, let's have a short break from here. So let's do this. Let's do it a 10-minute break and then we'll do the rest. So just by the way, we only have this lesson today and then you can catch up with the lab. So we have a quick break and then we'll finish up with the rest of the lessons. Alrighty, let us finish up today's lesson. So next up is customizing application behavior or custom application behavior. Now, so what is this? So custom application behavior gives you custom isolation or to manage behavior of your specific applications. It works alongside adaptive protection policies, and while adaptive protection helps you to manage a set of known trusted application, custom application behavior provides customized configuration. This provides a set of default rules that we create, default custom rules to provide options for immediate protection in your organization. So there's a nice hyperlink at the bottom that takes you to manage custom application behavior. So what can you do? So custom application behavior provides file and folder access protection against file and folder access, allows or blocks access to defined files or folders, launch process attempts. This allows or blocks monitored application processes, registry access attempts, and this protection allows or blocks access to registries, keys, load DLL, that defines the DLL dynamic link libraries or DLLs for which load attempts are detected, and also terminate process attempts, for example, defines the processes for which termination attempts are detected. Right. So let's look at these concepts. So this diagram shows you a breakdown of how rule sets and rules are processed based on their conditions. The rule for application 1, for example, allows it to go to a registry, processes, configuration DLL, but it blocks access to Windows directories. Application 2, on the other hand, is blocked too long. It's blocked, not allowed to access anything. Custom application behavior rule sets and the associated rules are processed in the order in which they are displayed. So from the top down. An application rule set will contain one or more admin defined rules. So you define the rules. Each rule set and rule has its own properties. So we have different conditions and rules. All right. In the rules, we specify what may or may not be done. If you create an application rule that block all processes, you could add exception for trusted processes. You can add specific processes that may be allowed in your environment or may be allowed to run. You can add trusted or untrusted processes. So this whole little wizard and algorithm of stuff on how we can do this in your environment, and you can also, this can be as straightforward or as complex as you like it to be. I normally tell it to be quite uncomplex. So we can do, for example, block an application, prevent users from opening a specific application. We can also create a rule that says that prevent users from writing to a specific file, block file shares on our Windows machines, for example, or specific other systems. We can also prevent users from running applications like peer-to-peer programming, etc. But then also block attempts and read and write attempts to DVD. I don't know who still uses DVD writers, but you can also block write attempts to all that. So how do we create that and create our custom rules? We may want to create custom application rules to prevent users from opening applications, writing to files, or sharing files. You can also review your default rule sets to see what you've done. So We can look at the behavior, for example, file and folder, launch process, registry attempts, load DLL, or terminate. And then the action is allow access, continue browsing, block, terminate, or also just logging. After you've determined which rule an application applies to, you can define the behavior and actions for that specific rule. You can specify what condition the behavior is looking for and then specify the action to determine what happens when an application meets the specific behavior. So when using the block, for example, the cap will prevent your custom application behavior will prevent the process from running. Terminate will kill the application. We do recommend, though, that you try to terminate rather than block. Block rather than terminate, because terminating an application could cause and make stuff unstable. So rather block and don't terminate. Okay. So, for example, when you start Minecraft, we use an example of Minecraft. So when you start Minecraft for Microsoft Explorer, the rule terminates the Windows Explorer. If we actually do block, users can still run Minecraft when they launch it directly. So instead, we use the block access action that blocks the target process of Microsoft launcher. So this is basically, so rather application to terminate will terminate Explorer, but not Minecraft. So, but if we block Minecraft, it will actually block Minecraft, not Explorer. So that's also sometimes something that's a little bit weird, where you just run something else. Your rules are defined using the process name, the application's name, the path, which is a system variable, could be a wildcard, regex, as well. So we can use versus wildcard, regex. Only match applications on specific drive types. We can also, so there's, let's go back to the drive types. What's this something? Devices or whatever. There's the device ID that we can add. We talked about that earlier this week. And then match the file fingerprint as well, which is then the fingerprint that we have there. How do we get these fingerprints? The best way is running the checksum utility. So you can create a file fingerprint list for a specific file, or you could create it for a whole system. So if you do it for an image, and this, by the way, the checksum is installed on each of your agents in a Windows system. So on each Windows laptop or desktop or server even, that's where it sits. So you type in or run a script or a batch file to say checksum.exe space C drive.c for the LR list, and then create a fingerprint list for a folder that's for the whole folder C file. So if we go back here, the syntax is checksum, the command, the output file, and then the path, which is weird. I would normally think it's the path and then the output file, but you first specify the output file. And the file is stored in the path that you designate. So here, checksum output file. So here is, it creates, for example, so checksum output file, and then the file. So we basically say, right, for SVC host is basically SVC host, run this, and that's the output file. So there's the file fingerprint, and this is the file. It's pretty straightforward. You can run this as a script or a batch file. Right. We use basic logic to evaluate behavior. So it's an if then else. So if the application or rule runs, evaluate registry access attempts, find a folder, launch, terminate DLL, and then take specific actions. A rule set is composed of multiple rules that are processed from top to bottom. So there's if rule 1 is equals true, which is SVC host that runs, for example, then for application, allow and continue to run rule 2 and allow create delete. You don't have to type this in like this. It's a wizard driven, so you can do it. I mean, you're not going to write a script, that's what I mean. But this is basically what happens in the background. It's composed of multiple rules processed from top to bottom. If one of the rules explicitly specifies not to evaluate following rules or continue following rules, it will stop. So here is allow create rule attempt, allow and continue to rule 2. But if you could now allow and block rule 2 and stop, that's also possible. In this example, Windows Updater, which is service SVC, I call it service host, SVC host, is the name of the rule. The rule prevents the saving of any exe or DLL file, except when it runs from Windows Updater. So if it's true, Windows SVC host runs, allow and continue, and then for application or process, accept specified application and block that. So Windows Update is identified by different processes, and all installers, all other stuff needs to be blocked. So the conditions to prevent the creation of multiple files, a regular expression is used. For example, asterisk or whatever will, so this is everything.dll, so all of the DLL or EXIs, EXE or MSIs files are located anywhere on the drive. That's 3 levels deep. So you can see they're 1, 2, 3 levels deep. And the second rule applied to all other applications that blocks the creation of your exe files. For rule 1, for example, Windows Update is allowed to create, delete, and make write attempts, and then allows rule 2. For all applications, you have create, delete, or write attempts are blocked as we do. So conditions and condition actions as well. So configuring your application behavior, custom applications behavior. Like with every policy, you start on the ICDM page, you go to policies, create a policy. This is going to be a custom policy. Click add. Now we're going to decide there's the policy templates. So remember, somebody asked me earlier on this week, remember there's a whole bunch of policies, templates that's there for all of us to see and to use. You can choose the policies, adapt the policy. And this is updated all the time by Symantec. So consider the default rule set before creating new rules. So you can find your rule set. We recommend that you consider the default rule set rather than creating your own. So here, basically everything will be blocked at this moment, but you can add this now in more detail. Block access to scripts. You can switch the status of the rule set to monitor. And then to block access to certain, you can use a predefined rule set. And from the custom rule set, select block access to scripts. Set the rule to monitor mode by selecting monitor. And click rule set ellipsis. And then select edit to view the details of the rule set. So edit or delete the step. To edit a rule, you select the rule name. And you can then edit. The first thing you see is the applications page. Here's your applications page. From here, you define the applications to which the rule applies. And this is a set of applications that are monitored for conditions that are in the rule. Look at your behaviors and actions that will display the supported behaviors, and you can see a number of records value if a behavior has any assigned conditions. To see this, you select the right pointing arrow for the behavior. So look at that and it will pop up that screen. The actions, you need to select the condition name to display the assigned properties. And from the properties page, you can see the files or folders to which the condition applies. You can select the condition name to display the assigned properties and actions. And from the action page, you will see the actions that's applied when the defined conditions are met. So block scripts, there's your reader terms. Do I want to, so here's that, what I mentioned earlier on. Do you want to continue this rule? Terminate process, allow access, block access, logging. Then any create or delete or write attempt, do you want to continue? So some recommendations is plan the rule, create a rule set and add the rules, apply the rule to specific actions, and then add conditions and actions to the rules. You can also test the new rules before applying to production. Okay, so plan, create a rule set, apply, add conditions and actions, and then test the rules to new actions. To create new custom rules, from the CAB policy, select add a rule set, provide a rule set name and a description, select add your new rule set is then added to the list. Always give it a nice descriptive name. For the new rule set, add a rule, select the right pointing arrow, and then add the rule, name and description. Define the processes or the applications that we want to block from running, other processes or applications, and we select save, so we can basically add included application. If we want to block all applications, and then we save included application, that's the name, whatever. In this example, we want to block an application from launching. So from the behaviors and action page, we will use the right pointing arrow again. We will then, to display the conditions, right? Yes, we then select add a condition. So we click that, add the condition. We'll call this block email. That's the app that we want to block. Then we'll add a process definition. That's just the name of the system. There's also the processes and stuff that we can use, the applications from the drive type or whatever. We want to block access completely, enable logging, and then notify this app is not allowed, and we click save condition. We're now ready to assign the policy and begin protecting endpoints. And by default, this new rule set is set to monitor mode. So we can now, monitor, it will just monitor stuff, and we can later on turn it on. Remember, we told the steps that must happen. We can verify that the behavior policy was assigned by viewing the ICDM policy tab page from the device group to which the policy was applied. We can also open the client and then access the help troubleshooting screen. So see that it has been gone through, and your clients see that it has default application. Behavior policy version 9. Version 9. Yeah, so this basically just, by the way, so these two menu items, cloud management basically refers to everything within the ICDM. How do we monitor this? Very easy. First of all, this is now in monitoring mode. So what we'll do, because the gap policy was set in monitor mode, when we launch the block application, it's allowed to run, so people can run it. But under the client control, it will be logged. Vasat was running in test mode and the rule name. So it was not going to block it. It is just going to point that it is doing stuff. We then, after switching it to on, so it's no longer in monitoring mode, it's now in on mode, or it's active. You'll see there it's now in production mode, no longer in test mode. And now the user, you will get this pop-up or the pop-up and the warning screen. Right, we'll see a Windows error message and the SES client message. Right, to view this in the ICDM, we can also access the investigate view and then filter by custom application behavior terms as well. Selecting an event shows its details. You run custom application behavior to filter this. All right. Custom application behavior, we looked at that, and then monitoring and creating events. We're almost done for the day, so it's looking at host integrity policy, which is the last big topic of today. So let's introduce host integrity. What is this? You use this to define and enforce security of your devices in the environment. It ensures that Windows devices are protected and compliant with organization security standards. If an endpoint do not meet compliance, they are then isolated through the use of a quarantine policy target rule until a remedy is applied. Right. So this shows host integrity components and how they relate to each other. So we just basically have conditions and actions similar to our rule sets. So each requirement specifies what conditions to check for as well as remediation actions. Each host integrity policy includes one or more requirements, and each requirement can contain one or more conditions and remediation. So let's look at this. Host integrity policy, or based on the compliance policy, include custom requirements against which the compliance of the device is checked. For example, you define a requirement to check for the existence of a Windows registry key. You can also use integrity policy to push custom scripts to your devices. So to make sure that they have the specific versions and specific software and everything installed. It's almost like a policeman checking all your applications and devices. Right. You can also install secondary software on a device. So make sure. There's also a nice way to push out. Let's say you upgrade. Maybe to use that other example, you're not allowed to use Zoom, for example, in your environment. So this is to block Zoom or to uninstall Zoom or to make sure that Zoom's not running or even force up a new version. So to add the requirement, you use a script builder. The order of requirements are very important. The first requirement takes priority. It's really an if then else scenario. You can enable each or disable each requirement, though, but the requirement is enabled by default. And when you edit an existing requirement, you launch the script builder. When you create or edit a requirement, you can choose to log but not enforce a requirement. Within the requirement, you can specify multiple conditions or functions. You can specify whether the host integrity check passes or fails each condition or function. Here you see a list of the options. So if then else. So you can go for more details. So the if statement is a condition like whether the device runs antivirus software, for example, or Windows or whatever. The then is the action to take if the condition is met, like downloading a file or go to the next step. The else is automatically added if you need to action something else if the statement is not met. In other words, if it doesn't run a specific version, if it doesn't run antivirus, or if it doesn't run SEP, maybe you're migrating from McAfee or Trend or whatever to SEP and then go. And then the end if statement ends the condition and resulting actions. Function adds functions to the script, and then return adds a pass or fail, and comment adds a comment to the script. Here's an example of requirement script that uses the if then if the iOS is Windows 10. So we basically look at custom requirement if OS is. So you decide the conditions. You can decide your own, add a condition or whatever, and decide Windows 10. Obviously, this is an old screenshot. Windows 11 is out, so it will have Windows 11. All right, pass or fail. You can schedule the check to execute on the devices to enforce a set of requirements according to specific settings. Do you want to always run this? Only when it's connected to the cloud or never run? Remember, this information and this orders will be packed out into the SEP agent on your system. Right. Check it every so many minutes or whatever. Notifications. Do you want to let the user see this? In this instance, I don't think so. I don't think it's worth letting the user see this. It's just going to annoy them and add some calls to the help desk. I don't see this. Shows verbose result in the security log. Yes. Display a message when the integrity check fails. Um, Again, I don't think it should be an issue. You should get the notifications as the administrator. But again, you decide on how it really depends on how strict your environment is. Um, so now we're going to run an example in basically blocking or disabling registry editor. So if the operating system is Windows, then basically you set the registry value to 1. And the registry value that scripts is basically, well, so set a registry value, which is then disable registry tools. And that is then to block the endpoint or block registry editor. Um, a lot of these scripts, you need to do some research, guys. You need to know what you're doing. You need to research a little bit to see what kind of scripts and stuff and how you need to do this. It needs a little bit of mindset of coding and robot writing. You can then set account its restrictions, and this restriction applies to the endpoint. And if the endpoint is running 10, Windows 10 requirement is designed to run a script. And that's a script, for example. So you can change the account script to lock out, change the lockout settings. So again, you need to understand a little bit of scripting and stuff, and to do some research. I think there's if I recall correctly, where's this? No, some a tech note to just go through this. Yeah, there's a whole bunch of on this page. So if you look at here, these are hyperlinked. You can gather more information in the Broadcom websites. You're going to need a little bit of, like I said, coding experience and understanding of this to really, although you don't have to write the code yourself, you need to understand the logic in here. So I would suggest with host integrity policy, just go and play around with it, test it, see what's happening, and understand. Make sure you understand how this works. So let's investigate the host integrity check. Viewing the activity, obviously we're going to go and look at investigate, and then we decide what we want to do. We can check for host integrity. You use the investigate view to view your host integrity activity. You use a custom filter to isolate host integrity events in the investigate view list. As mentioned, host integrity policies are assigned to compliance policy template. And then to isolate these events, you can add a custom filter as well. So with different field IDs like event ID, filter by event type ID, specific IDs, and messages or whatever. All right, once you filter that, now you'll see. To isolate the host integrity failed events, everything that's failed, and message failed. You add a custom filter with IDs, operator, compliance value is 8071, and the value failed. Viewing host integrity activity at the endpoint level, you can see this on your endpoint troubleshooting under cloud management, also under the security logs as well, and see there whether it's failed or passed, and you'll see this information of your host integrity. You can also use this log view. I don't think many end users will really do this, but it's nice for you to troubleshoot. If a check fails, you could see some activity on the endpoint, and the endpoint will display a failed message banner. And after opening this, the client status window will display a failed security compliance message. When you select Help Troubleshooting, the host integrity status field is set to fail. Remember, the location is changed to quarantine and failed. Right, and it will talk about quarantine just now. You can also use the application log to track host integrity activity. So here, again, log to check your activity, if it's failed or not. So you'll see there's one warning, it's failed its security check and security compliance scan failed. If it's log only, it will basically fail, but reported as passed because it was log only. So if it's had a log, it will say it's failed, but reported as pass because it's not going to block that or quarantine. Because auto quarantine, we talked about this yesterday, is when an endpoint fails a host integrity check, it will automatically be quarantined. All right, switch to policies that were assigned to devices in quarantine. These are obviously much more restrictive. General network access is blocked, but access to the SES complete, the ICDM and stuff are still valid. Host integrity can be configured so clients continue to remediate. So you can still access the machine, you can run a PowerShell script and those kind of things, but the user can't get his email, for example. So the policy target rules to automatically assign based on specific conditions, and we include default and quarantine policies out of the box. And these policy target rule is used by the host integrity compliance process to automatically assign policies to endpoints that have failed a compliance check. To add to quarantine policies, basically create a desired policy, apply policies, select a quarantine, and then submit. The original policy list includes a firewall policy called default quarantine firewall policy. This was an example of a policy that is used after compliance check failure, and you can see that this policy is much more restrictive than the default firewall policy. In fact, this only allows for 4 DNS domains to be accessed. All other traffic is blocked. And that's the ones that it's allowed, the internet access that's allowed. So then the next step to assign policies. So select apply, group hierarchy, select a rule, and then submit. And then you can do the assign quarantine policies. Select the policies tab, and there we go. Assign quarantine policies. So basically, when a host integrity check fails, all policies will be added to the quarantine. All the policies that are assigned to the rule are automatically assigned. So anything. So when you fail the host integrity check, it's now very strict. So it will lock everything down. As soon as the endpoint passes the integrity check, it will now be removed from the quarantine. Okay, so we looked at host integrity, the components, the scheduling, and the scripting, how to investigate, and then the quarantining. This was reducing the attack surface. Introduction to surface reduction, says autocomplete, how to use adaptive protection, and the host integrity policy. So there's a nice lab, which is the ICDM. Use the tools provided to run this. Detecting and blocking, setting up a default, adjusting application, blocking unwanted applications, using device host integrity to harden the endpoints. So let's just go here. Let's see this machine. So PDF, lab guide. Ta-dum, ta-dum. So this is basically page 133 up to page 160. So it's about 28 pages of labs that you have to do. The great thing is we have 2 labs left, which is basically going to be 2 shortish labs. We've got 3 lessons left. We've got mobile device, threat defense for Active Directory, and then on Friday we have lab for the hybrid environment. Okay. Sorry, let me just go check some messages now. All right. So, Satyam, you sent me a message yesterday. Sorry, I didn't see that. I have to tell you, I did a very stupid mistake. You will laugh at me. So, especially you guys. Well, you all got spicy. So, what's today? What was yesterday? Tuesday night. Tuesday. Monday evening, I did some stuff and I made a curry at home. Just a little bit more of an Indian curry than a Southeast Asia curry. Anyway, like an idiot, I chopped up 2 bird's eye chilies, but like an idiot, sorry, the first part was not like an idiot. I chopped up 2 bird's eye chilies, but like an idiot, me did not use gloves to do that. That's not the biggest problem because you can wash your hands. Obviously, my hands were tingling and everything I touched. Monday evening, so I have to tell you, that's why you see my glasses just early in the morning. I normally wear contact lenses. So Monday evening, I remove contact lenses and things a little bit not so bad, but go to sleep. So yesterday after the training, I decided to have a shower. As like I told you, I normally have breakfast. It's 7 a.m. here, so it was about 7:30 or 8 o'clock my time yesterday morning after the lessons. I decided to I had a shower and put my contact lenses in. Oh my God! I nearly died. My I had to shout, not shout, but call my wife that was already busy working to come and help me because this is what I look like. Where's this? So, here's this now. See my eyes? So this is after I removed my contact lenses because I had to actually, I mean, I couldn't, the contact lens is now my eye and it's burning the crap out of me. So I had to remove my contact lenses. You see how red it was. So the whole day yesterday, I couldn't wear contact lens. Just I only wore my glasses. So today, hopefully after showering, I've washed my contact lenses and hopefully there's no more chili residue on my fingers, but I almost died. So, Satyam, that's why I didn't reply to you yesterday. I didn't see your email in the morning. And then I saw later on that you did come, right? I apologize. That was so funny. I hope you're having a nice giggle on my behalf. That was such a rookie mistake. Oh my gosh, I can't believe I did that. It was so stupid. Anyway, sorry about that, guys. I am much better. At least my eyes are not so red anymore. You can see in the screen. Okay. So sorry about that useless info. I'm sure you feel much closer to me. That's it, guys. We have a lab to do. Any apologies for this morning? I have no idea why. Maybe it was me. Maybe it's completely possible that it was me. But sorry about that issue. Glad that we could get everybody back into class. So, any questions? Otherwise, speak to you tomorrow. Cool. See you later.
Hà Nội thứ bảy phải lên đô, đi xem dân tổ phía bên hồ. Người chờ hệ phóng xăm trổ, đang đua bị chốt bê lên đồ. Anh lượn một vòng hết phố cổ qua ma mây. Thằng homie anh trên phố đang hustle với mấy gã tây. No limit trên đôi BT, đi săn mồi và bắt đầu flow. Rapito cộng thêm backstage khiến các em phải hit the wall. Người Hà Nội xin là phải chắc như anh LK, game âm nhạc bọn anh giải nhất. Nghe đi em ơi, muốn chơi như anh chú chưa đủ sức. Thanh niên đang cay cứ như tên lửa bọn anh phóng về đích. I'm on my way. Anh em sắp cánh luôn kế bên, bọn anh chiến thắng ở trong mọi game. Hà Nội nhiều biến nên đừng quên, bài học đầu tiên là đừng tin. Let's get it.
Tao vẫn ở để chơi đùa, chúng sổ số nên hơi rùa. Phóng ra trả trên đê nằm một kim liền gặp gái tao không có hơi hùa. Flex sở đống đã hệ thủy, em phải ngắn đến tên thủy. Rủ tao ăn kem trả tiền nhưng ngọng lờ nớ hủy. Lãi suất bành với đáo hạ tao là có thêm tỷ phần trăm để mua được đôi giày. Tiền năm nay hơi dư giả vừa nâng lên future trước đấy đi wave. Ông nội tao làm thầy đồ, họ nội tao với chuyển thần. Từ Đồng Xuân Việt Nam Đồng có thằng cháu trai đẹp trai nhả vần. Phóng ra mây anh Tuấn, MCK ở Circle K. Gọi thêm Mess và Jean và Zenly đi chơi Hồ Tây. Dẫn lên Last Fight Crew, phòng tập có bùa chú tích đức tích phúc. Hit the wall, hưởng lộc từ các cụ. Anti-art gọi cho tao từ chiều. Nirvana tại chợ quần áo, thôi anh tủ em còn nhiều. Hai nỉ tiền thứ bảy tuần này còn cà phê trà sữa bún đá. Ấy nhầm, bậy sữa, cà phê sữa trà đá bún chả.
Có thằng bị đánh không thương xót, vì sao? Vì ăn bún đậu chấm tương ớt. Có thằng bị thí như con tốt, lên không mua vẫn đi vào trong chốt. Né khỏi drama, người chơi hề nước, ký bản hợp đồng như là ký bản thể ước. Mày bắt đầu khi phải đi ra về trước, chân đi nhẹ bước khi đang là không phải tốt như là lật trứng. Phản bác lại bằng cách nói những điều thật đúng. Để có show thì nơi đó cho nên chật cứng, cầm cái máy như khách bộ đội cầm súng. Let's go, yeah. Bước lên từ con phố Hòa Mã, đi qua bao nhiêu giải để họ biết đến tên mình. Bách xe miền Nam lên hình, làm họ nhớ đến anh vì có flow của riêng mình. Được rồi đi thôi, giải khắp thành phố như aha. Kiếm cho cái ví đầy mana. Round zone bệ phóng như NASA. Bách xe đưa anh lên radar, tài năng đưa anh đi ra xa, ra khỏi mấy thằng bao hoa. Bắn drop như một khẩu AK.
Bitch, có biết thì phải gom ra đây, ha, để thằng Long ra tay. Bitch, om mày như là om ba cây, ha, phòng trên Honda A. Bitch, đi ăn vừa hại là phải hở, ha, bọn tao kiếm được nhà tài trợ, ha, flow tao vừa chắc lại vừa đầm pow, Anaconda A. Bitch, hôm nào cũng xôm như là hội, tưởng là tư sinh nhưng là trọi, chơi vần chất ở những nơi sầm uất và cả đội ở ga Hà Nội. Sáng dậy sớm qua Lenin, bắn thuốc lào uống cà phê phin, xem anh em bọn nó chơi skateboard, hip hop thủ đô không bao giờ là hết hot, ha, bitch, không bao giờ hết hot, ha.
Lâu nay ta quên nhau chưa, lại cả anh viết vẫn đó dấu vết cơn mưa. Thà là em xóa hết để của một lần đau, nhưng em đâu biết có phút chốc ta cần nhau.
Câu đau lòng ăn dấu.
Cho anh là họa sĩ, em là hoa, baby. Xem như mình đang vẽ lên bình yên, baby. Anh đang tô màu lên mắt em, một màu xanh rất hiền hòa. Anh luôn nhìn cuộc sống như văn thơ, baby. Chơi vơi trong ngàn câu chữ như là mơ, baby. Nghiêng nghiêng đôi vai để em gối lên hàng đêm. It's gonna be alright, girl. Nếu cứ sống cho những mê man, chìm sâu rồi nhận ra em đâu còn đây, sương khói giăng đầy. Bàn chân anh đi tiếp đi tìm em trong màn mưa, mưa lạnh hơn. Làm sao xóa dấu vết em đã tim này. Giấu em vào niềm tin mình, giấu em trong đôi mắt tình. Vì mưa biết nơi anh giờ này. It's nothing in my heart, in my heart. Và mưa cũng giống em, lạnh lùng vô tình. Giống em luôn yêu chính mình. Hãy cứ để mưa rơi nhẹ nhàng. It's nothing in my heart, in my heart.
Lại một ngóc anh đó không phải mưa đâu. Góc đường nào ta đón đưa nhau, phố nào ta đã cười nói khung trời nào bên vấn phương đầu. Gió nào trên tóc em mượt, thu nào ta nói
pass I much more.
những ngọn đèn mơ vội tắt, mơ rơi trong
phía sau.
Bada bing, bada boom. Bada bing, bada boom. Bada bing, bada boom. Bada bing, bada boom.